Hello everyone to another breakdown, and today we're doing a breakdown on the vortex dynamics of the recent Dodgeville tornado. It piqued my interest in how this tornado had similarities to other tornadoes we've seen before, and so I thought I'll do a similar discussion based video as we did last time for the Western Pacific Typhoon update. You can check that one out, and it should be in the description, but this video is going to highlight this vortex dynamics, and it's going to be relatively short, hopefully. Last time I said it would be short, but it's quite long. But nonetheless, this diagram and this diagram is what we're going to be using a lot to reference. So on figure 1 we have the date of 15th of March 2024, which is the Wapakoneta, Ohio EF3 tornado. And then you've got the Dodgeville, Wisconsin tornado. Some of the footage has been difficult to find, but this is a footage that I was able to, was allowed to use, and so you can clearly see the tornado here and here. So my notes I have written alongside we should discuss these tornadoes. And so one of the first points I made was the Wapakoneta tornado has a very similar unstable vortex, where this tornado is likely at peak intensity and there was no longer a multi-vortex stage. Multi-vortex meaning a large sort of region of interest, area of influence of the mesocyclone, with multiple subvortices underneath the mesocyclone influence. And not typically when you have the mesocyclone and a multi-vortex feature, you have these sort of rapidly condensing streamers that you see, particularly in certain setups like a MCV setup. You got these rapidly condensing streamers that form the subvortices of the mesocyclone, on the multi-vortex in the mesocyclone. And one of the other things was that this was likely a rapidly condensing tornado. I mean, there is video footage of this, so I should be able to put this in the description, but this sort of tornadoes, both of these, were rapidly condensing. So you had this sort of uncondensed funnel that had rapidly condensed into, well, at least a visible stovepipe shape with the tornado, and likely you've got drill bit motion above ground level, so just within the surface layer you've got sort of drill bit motion likely in present. And that was one of the things I saw, especially when you look at the footage of the way these tornadoes display the motion, because a still image doesn't necessarily reflect that. And another point is that you have a rapidly condensing tornado that is already on the ground, and that's typically uncondensed funnel to a full condensation, as I've just mentioned. So that's one situation. So this is sometimes a misconception with this, so that's why I've labeled it A and B. But you have this rapidly condensing tornado like this from an uncondensed phase. Typically you'd see like this and some sort of ground motion, but this is one phase that you have a rapidly condensing tornado, typically from an uncondensed funnel to a full condensation. And then B is when you have a rapidly organized funnel that is typically an unfavorable looking supercellular structure to rapid tornado genesis. So one is already has the tornado on the ground, and then the tornado is then intensifying, but the other one is a progression towards tornado genesis. And both are slightly different, but they are something that can be quite confusing because of the similarities between them. And so again, both of these tornadoes at large displayed A, where you had this tornado on the ground and then it had produced full condensation, as opposed to B. Another perfect example that I had found was the Joplin tornado. So the Joplin tornado had phase A really well defined, because you had a tornado already on the ground. In fact, it was multi-vortex, just as I mentioned, and this was basically a snapshot between about 6 seconds. So you have this sort of, you can already see the sort of region of where the condensation will occur, and you've got this sort of aggravated condensation that's being I misspelled that one. It's supposed to be agitated condensation, but you've got these condensations that become aggravated near the surface, and then they become this full condensation base. And that's typically when you have a cyclostrophic balance between the inner condensation, and you have the right temperature, humidity, and pressure differential to allow for full condensation. And typically, when it's rapid, there's likely large supercellular feature that is going to be provided for such a rapid condensation. One of the things, I don't have the screenshot here, but one of the things I do remember very well was from the Joplin supercell, you had a very quick merger interaction between two supercells, and so you had one dominant supercell, and then B, you had a backbone sort of RFD. You had this very west to east moving supercell with a very sharp backbone and a very strong RFD surge that wrapped around the circulation, that probably induced quite a powerful dry slot around the circulation. And again, such a strong RFD surge can initiate tornadogenesis perhaps quicker than a situation where it's not as powerful. And this is going to be just a mention to Convective Chronicles video, because his video has an explanation of the Winterset, Iowa tornado, which is another great example. But this tornado had displayed both A and B, because you had a rapid condensation, and also B, you had a supercell that was sort of back dog-legged shape, so it did not look favourable, and it was not on the ground. You had this sort of you had a wall cloud base that looked like quite flat and almost a horseshoe sort of shape, which would not look as robust. But then tornadogenesis occurred very quickly right after that, and so you had this sort of supercell that is imaged here that allowed for the tornado to form. And it's linked. The link will be in the description. And I wasn't quite sure if I could get footage or pictures of this tornado, so I only took this as a mention to watch the video itself. One of the other points was probably more about a claim that was produced by a lot of different media when they saw the Dodgeville tornado. A lot of people, at least enthusiasts you could say, kept saying violent tornado during a period at which the footage didn't display the same thing. And so first of all, talking about the vortex dynamics itself, you had likely a medium swirl type core, so the core is going to be within the central part of the circulation where the highest damage is typically produced, and you have the medium swirl type core. So the swirl, typically you have like a high swirl ratio and low swirl, and this is sort of in the middle. So it's kind of, so the swirl ratio would be in the medium between both, and so the strongest intensity at the base of the circulation would occur for short periods of time in the core, and so you probably get these sort of instantaneous gusts near the surface. And it was this sort of same description was actually described with the Gary tornado that I mentioned, and like the Ashby tornado. And again, one of the claims was that the tornado produced horizontal vortices, but instead during intensification, it was actually during intensification with rapidly rising condensation and likely a breakdown bubble in the horizontal that produced a visual that looked like it was a horizontal vortice, but it wasn't actually. And so we're talking about not an actual high intensity sort of feature that you typically associate. More description behind this. So regarding the multi-vortex stage, you had a rapid vertical acceleration. So from drone angle it was better to see that it demonstrated these rapidly condensing streamers under the pressure deficit column, and you had a horizontal tilt that is rising and becoming vertical as it reaches the upper part of the tornado, which suggests intensification. You also had it was the intensification phase, not maturity, which meant the tornado had extremely tight subvortices that do reach down, and if any of those do make near surface contact, these small concentrated areas of vorticity likely could be more intense. An approximation based on the damage of the aerial footage higher in EF1 intensity. So certainly not the descriptor that would fit violent. And again, this picture on the right is likely at peak intensity with the tornado. And the last thing I have to say was an example of the tornado, which is the Hackelberg 2011 April 27th super outbreak, tornado year 5. And again, another perfect example of this intensification phase, not maturity and not likely already violent. So this is not a violent intensity phase. You've got a tilted vortex, and this is the intensification phase. And then this is the maturity phase. You've got like, the maturity phase is quite a broad phase, and typically you get these sort of peak intensity damage indicators within like the heart of that maturity phase, where the tornado is going to be fully condensed, this sort of base funnel. Typically not always, but because there is some examples like the Sailor Park 1974 F5 tornado, which is not quite the same, but you have a tornado like this, Hackelberg tornado, where this is now talking about violent intensity, the maturity phase, this image on the right. And yeah, that is mainly what I was going to discuss within this video. If there is any other questions, then do let me know, and I'll see you guys in another video.